Okay, now let us start with new topics of capacitor. Let us begin with one question. Good question. It is this type of question usually comes in your exam. Now let's begin with this question. Okay, let me discuss this question with you first because it is the most important question. This type of question usually comes in your exam. When we are discussing about this question, what we will do, we know that first thing, important thing, you should remember that this, if whenever we are having one capacitor, imagine I am telling you one shortcut trick, one shortcut trick. You should remember this. Okay, if we are having one capacitor, having capacitance C, if what we do, if in this capacitor, what we did it like this, we cut this capacitor in two equal halves like this. If we cut this capacitor in two equal half like this, okay, if we cut this capacitor in two equal half like this, okay, like this, if I cut this capacitor in two equal half like this, what will happen? Then this capacitance C will be here. It will be C by 2 and it will be C by 2, and both will be in the parallel connection. Both will be in the parallel connection. You can see, because it is equivalent, it becomes equivalent to like this, C by 2 and C by 2 like this, C by 2 here and C by 2 here similarly. Okay, first thing you should remember. Okay, second important thing here, shortcut. If suppose I cut the capacitor in two equal halves like this, now it will become two capacitor again. Here capacitance will become 2C and 2C, and both are in series combination. It means that 2C and 2C like this, 2C and 2C. Okay, and both are in parallel combination, and their equivalent will be C, and their equivalent will be C. Okay, any problem? Its equivalent will be C, and here also equivalent will be C. Okay, any problem in the shortcut? Remember this, none of your question will be left of this type question. Okay, now let us see how to solve this question. It is given that we have cut this capacitor. You can see we have cut this capacitor like this, this means this will become, first we have cut in two equal halves, it will be C by 2, but C by 2 cut from here. You can see we have cut from here. What it will be? C by 2 into 2 and C by 2 into 2. Any problem to anyone? We can draw it like this. We are having two capacitor. One is C by 2 here, and another is like this. It is C, and their equivalent will be always C. You can see. Okay. Any problem? Okay. Now let us see. Now it is given that we have filled with K1 is equal to 3. This means we know if capacitance is equal to epsilon naught A by D. We have studied, if a dielectric is filled, then it becomes K into C. K times increases capacitance. Okay, now what we will do here, to C, K3 we are adding, and K3 value is 4. Okay, what will happen? We have to multiply 4 here. Okay, K2 is given is 6. We have to multiply 6 here. K3 is K1 is 3. We have to multiply 3 here. What it becomes? It becomes 2C. It becomes 2C. It becomes 6C, and it becomes 3C. That means we will say it will become 6C, it will become 3C, and it will become 2C. Okay? And their equivalent will be how much? 3C and 2C. Series with each other. We know two capacitance in series combination. What we will do? 6C into 3C by addition of both of them, 9C. Cut here. You will get here what? 2C. And this is also 2C. 2C, 2C parallel. What we will get? We will get C equivalent is equal to 4C. Any problem to anyone? I have used shortcut to solve this question and I have discussed this shortcut here. Any problem? This is a very important question. Yesterday, I think I had given homework. Okay? Okay, good. Now, let us move further. All of you should interact. Okay? Okay, please make the session interactive. Now, let us try this question. Let us try this question. Try this question. Try this question. This is having a three capacitor. One is K1, C, and dielectric field is K1. Another is K2, and the third one is K3, like this. And it is telling that we are having equivalent capacitance of point C. Their equivalent capacitance is 0.5 C. That means C by 2. Okay, and it is telling that C capacitance of each capacitor is C in vacuum. Remember, so if K1 is filled, what it will become? It will become K1 into C. K2 filled, then it will become K2 into C. K3 filled, it will become K3 into C. You know, these two are in series combination. What we will do? Upper part, their equivalent will be multiplication of their in series. What we can do? K1C into K2C by addition of both of them, K1C plus K2C. We will get here what we will get. We can cancel here. We will get K1 K2C by K1 plus K2, like this. And if you have studied, this is also the grouping technique of two dielectric. If you remember, if you have studied that, if two dielectric K1 K2 are in series, their equivalent is obtained by this formula also. Okay. Third one is K3C. In parallel with this, what we can write? We can write K3C plus K1 K2 by K1 plus K2 into C. It will be equivalent given is 1 by 2C. You can solve this and you will get the relation between the K1, K2 and K3. Okay? Any problem? You can ask, you can get the answer after this, solving this. Okay? Okay, now? Please interact, all of you. Please interact. Why did you use C by 2? Okay. Because it is given that equivalent capacitance is given. You can see here. It is given. Total equivalent capacitance across A and B is C by 2. You can see 0.5 C by 2. So I find this equivalent to the left hand side and equated with C by 2. Okay. Now let us move further. Now, let us move further and we will see here spherical capacitor. Now, let us suppose we are having one spherical capacitor like this. Inner sphere, solid sphere, is having a positive charge of plus Q. Outer sphere, it is just like a shell. It will have a charge, let us suppose minus Q. Let us suppose it is having a radius of A and outer is having a radius of B. Then their equivalent capacitance is given as what is it is 4 pi epsilon naught, 4 pi epsilon naught A into B by B minus E. Okay, this is the formula of spherical capacitor having radius of outer radius is B and inner radius is A. You should remember this formula directly. Okay, first one. Second, if we are having only isolated sphere, that means let us suppose it is given that one sphere is there present and is having positive charge like this. Okay, you have to find the capacitance of this capacitor. If we are having positive charge and negative capacity, negative plate is not given, we will assume that its negative plate is at infinity. Okay, and its capacitance is given as 4 pi epsilon naught, and if radius of the sphere is r, then we write 4 pi epsilon naught r. This is the formula for isolated sphere. Okay, any problem to anyone? Any problem to anyone? Okay, now third one. If we are having, it is a most practical capacitor. If we are having one cylindrical capacitor, okay, if we are having cylindrical capacitor such that its length is L, inner radius is A, outer radius is B, then its capacitance is given as 2 pi epsilon naught L by ln B by A. Okay, any problem to anyone? Any problem to anyone? Okay, one question for practice. Let me see, there is a no, it is not present. Okay, one question for practice. Find capacitance of earth having r is equal to radius having radius r is equal to 6400 kilometer. Okay, I give you 10-second time. Calculate, please calculate. It is telling that capacitance of earth. Assume earth as a isolated sphere. Assume it is like a isolated sphere and calculate it. Calculate, please calculate, all of you calculate. I give you 10-second time. Any answer? Any answer? Any answer? Okay. Nobody? What we know? We know C will be 4 pi epsilon naught into R, and R is given as 6400 kilometer. We can convert it in meter like this. 4 pi epsilon naught. We know 1 by 4 pi epsilon naught is that. We will write like this: 10 to the power 9 by 9 into 6400 kilometer into 10 to the power 3 converted to meter. We will get here 711 microfarad. You should remember this value also, and also you can calculate from here. Okay, any problem to anyone? Please interact. Any problem to anyone? You can ask. Any problem to anyone? Any problem to anyone? You can interact with me. Any problem? So why did you put it? Okay. We know like this. We know 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. 9 na? Okay. That means 4 pi epsilon naught is equal to 10 to the power minus 9, I think like this, 10 to the power minus 9 by 9. Here it will be minus 9, I think then. It will be minus 9. Okay, got it. Yes, sir, I got it. Yes. Good, I got it. Mistake, calculation mistake. Okay. Now, let us move further. Now, this is also one of the important topic. How much energy is stored in a capacitor? To find the energy stored in a capacitor, what do we do? Let us take one capacitor here, C, having capacitance C. We connect it here with a source battery, it is V, and let us suppose it is supplying here charge Q. At an instant, it is supplying a charge Q dash. Q dash will go here and get accumulated over here. Okay. Let us suppose maximum charge which it can supply is equal to Q here. Okay. We know that this Q will be equal to C into V. Okay, this will be maximum. So after doing this calculation part, we get energy stored in capacitor U is equal to half Q square by C is equal to half QV is equal to half CV square, and this is the most important formula. You have to remember this. Very important formula. Lots of numericals we can solve from it. Okay, where C is capacitance, V is potential applied. Okay. One more thing you should remember here, this energy stored is where? This energy is stored in the electric field. Okay, I have mentioned here this question when you ask your NEET exam, where is the energy stored? In the capacitor. The energy is stored in the capacitor in electric field. Okay, you should remember this. Now we are trying to find what is the energy density. We define energy density is equal to energy stored. That means we know half CV square. That means we can write C for parallel plate capacitor. We can write energy density is half CV square. That means energy density is equal to energy stored. Energy stored means half CV square. Any of the formula from this, usually we take this formula and this formula. We use this formula. We can use any of the formula. By what is the volume for a parallel plate capacitor? If it is having area A and length between the plate is D, then its volume will be area into distance traveled D. What we will do? We will divide here, and after dividing this, we can solve like this. Capacitance, value of capacitance, we can write like this: epsilon naught A by D into V square by area into D. Also, we can write like this: a half epsilon naught A by D into, we know voltage is equal to energy by distance whole square. Okay, now like this. After putting these values, we will get, all things will get cut here. Area cut, D cut. We will get U is equal to half epsilon naught E square. This is the formula of energy density, and you have to remember this formula. Very important. This formula and this formula. Okay. I'm not dealing with the that part, derivation part, because it's not important for your exam. Okay. Any problem to anyone till now? Any problem? Then what we get? You can write here what we get. We get half QV is equal to half CV square is equal to half Q square by C. This is the energy stored in capacitor, and also it is said that energy density is equal to half epsilon naught v square. Okay, if it is tell that if we fill capacitor with dielectric, if we fill the capacitor with dielectric K, then U will be equal to half K times epsilon naught. Similarly, what we have done earlier also. Okay, this we have to remove. We have to replace the epsilon naught by K epsilon naught if dielectric is filled completely. Then okay, any problem? Any problem to anyone? Okay. Now, let us move further then. Okay, let us move further. Now, we are dealing here, if suppose, let me give you one question. Let me give you one question here. For practice. One simple question for practice. What we do? Let us. We are having a dielectric K is equal to 80. We have filled here water, and if what we do, we are having like this. Here K is equal to 40. Okay. Now if what we have done here, if we have joined it with 10 volt such that energy stored is equal to 10 joule without any loss, then find C. And what is C? C is the capacitance in vacuum. Okay, you can find. I'll give you 10-second time to think upon it, and you have to try. All of you try this. All of you try this. Try this, all of you. Any answer? All of you try this. Any answer? Okay, no worry. Let us see how we can solve it. Let us see. You have to move further. Let us see how we can move. We can solve this question. Let us see. What we will do? We know its capacitance will be 80C and its capacitance will be 40C. Also, we know that their equivalent, C equivalent will be 80C into 40C by 120C. CC cancel 3 times here. It will be 80 by 3C capacitance. Okay, good. Let me try. C equivalent this one, and it is given that energy stored is 10 joule. Okay, 10 is equal to half C 80 by 3 to C into V square. Solve this and you will get the answer. Okay. Anyone, any problem? No problem now. Any problem? Yes, no, please interact, all of you. Please interact. Okay. I need response from you all. Okay. Now, let us move further. What we see here, it is a very important case. Remember, very important case. It is given that we are talking about sharing of charge and common potential. It is given that if suppose what we did, we take one capacitor here, one capacitor here, and one capacitor here. We charge this capacitor by a potential of, it is having C1 charge, a capacitance and voltage V1. And second capacitor, it is charged through a voltage of potential of V2, and it is capacitance having C2. What we are seeing that here, that it will get, after full charge, it will get Q1 is equal to how much? C1V, and here minus Q. Here we will get plus Q1 dash will be C2V2, like this. Okay. Now what we did, when the two capacitor get charged, this was having positive charge, and this charge was Q1 is equal to C1V1, like this. Okay, C1V1. Okay, what we did, we take this and we joined this with another capacitor which was charged here, C2, and we know such that their positive plate are at same side and negative plate are on same side, like this. After doing this, what will happen? We have to know, we have to tell what will be, how the charge will share, and what will the common potential attained by them. We know, since they are in parallel combination, after some time what will happen? This capacitor and this capacitor both will be in parallel combination. So after some time they will have attain a common potential here. Capacitance is fixed, C1, C2. It will have a charge of Q is equal to C1V here, and it will have a charge of Q is equal to C2V. Okay. Okay, now Q and Q dash, let us say Q and Q dash. Any problem till now? After doing all this thing, always remember one thing remain constant. After any operation, one thing remain constant: charge is conserved. We know, we have learned the property, charge is conserved. So initial charge, it was having C1 V1 plus C2 V2. We have seen it will be equal to, final charge will be C1V plus C2V. So from here we will get final potential will be C1V1 plus C2V2 by C1 plus C2, like this. This will be the common potential attained by them. Very important. You have to remember the steps. Okay. After knowing this common potential, you can get Q1 here. If we tell Q here, then we will get C1 into, after getting V from here, we can get like this, and we can get Q dash from here, Q dash from here. Q dash is equal to C2 into V from here, and we will get our answer. Okay. Any problem? Any problem in this case? Any problem? Please interact, all of you, please interact. Sleeping or what? Not interacting? Any problem or not understood? Tell me, please tell. Okay. After telling, let me check. It's okay. That only. Okay. No worry. This is an important case, and you have to remember this. Okay. Let me repeat it once more. Okay. Now, let me repeat it once more. What I told you, if we are having one capacitor C1, here one capacitor C1, it is connected with V1, it will get some charge Q1 is equal to C1V, and if we have connected C2 with a potential of battery V2, it will get a charge of Q1 dash is equal to C2 into V2. This is the charge they are having. Now, What we did, we joined them together, remove their battery, remove this battery, remove this battery, and we join them together such that positive plate of one capacitor, such that positive plate of one capacitor is positive plate of one capacitor is in the same side of positive plate of another capacitor. Negative side of one capacitor is in the same side of negative side of another capacitor. Then after some times, since they are parallel combination, what will happen? After some times, they will attain a common potential V. Then after attaining the common potential, they will get a new charge distribution on them, because the charge, they according to their potential, charge will flow from one capacitor to another, and after some time they will get attain equal potential. And after this we can calculate what will be the charge on equilibrium. So Q will be C1 into V, C1 into V, and Q dash, how much it will attain is this, C2 into V. Okay. Now what we do? We do charge is conserved. We tell, since we know charge is conserved, initial charge C1 V1 and C2 V2. C1 V1 here and C2 V2 here. What we tell? We are telling initial charge from here and initial charge from here, that was C2 V2. We add up both the charges on the LHS side. Before joining the joining they were charged this much. After joining, the charges got distributed among themselves, and the final charge will be C1V on this side and C2V on this capacitor. We add up there and we find the common potential they will attain. If we get the common potential, we can see here, if we get the common potential here, after getting the common potential, we can calculate this charge Q and Q dash like this. Put here V, and where we can get the charges also. Okay, now clear or not clear? Now we are going to discuss second second case. There you can get more clearance. Okay, let me see second case. I think this will be also very much clear to you. Now again, same things. What we are doing, we have taken two capacitors. One is C1 and it is connected to V1 like this. Another capacitor is C2 and it is connected to V2 like this. It will get plus Q here, minus Q here, plus Q, let us suppose plus Q1 and plus Q2 here and minus Q2 here. What will happen? What will happen? After some time, we can say this Q1 will be C1 into V1. Okay, and this will be after charging C2 into V2. Now, if they are charged, what we do, we connect them like this. Connect them like this. But what is the difference between first and second case? This time we have connected like this. Positive plate of one capacitor, we have taken here as minus plate, minus of another capacitor like this, in opposite direction, like this. Okay, any problem? No. We see here, after doing this, what will happen? After doing this, what will happen? What will happen? It is having a charge of C1 V1 and it is having a charge of because this type of question comes in your exam. Usually this is the loss of energy. By doing this, loss of energy occurs, but since it comes in your exam, yes, condition for both the cases. First case was that we have connected positive plate with positive plate. Okay, second case is that positive plate of first capacitor is connected with negative plate of another capacitor. Okay, no, it will depend upon the question. We have to see in question it will be telling. We can't decide like this. In question it will tell how we are connecting. I will show you the question also. How the question comes, how you have to decide. I will show it. Okay, okay. Take some patience. I will show you. I will show you now. We know since they are connected like this, it is having at this side C1 V1 and there here it is minus C2 V2. Okay, so we will say initial charge C1 V1 before when we added here minus C2 V2. Okay, after some time what will happen? Both of them will get same charge, same potential, like this. It will get how much? C1 here, C2 here. It will attend how much? C1 into V1, and here charge will be C2 into not V2. It will be only V because we are having, it is called as, let us suppose Q1, Q1 dash, and it will be Q2 dash. Okay, after this arrangement, final charge will be C1V plus C2V. Okay, C2V. Okay, then V will be C1V1 minus C2V2 by C1 plus C2. Compare this. You have to remember the step, or you can remember the formula also, but step is most important. So after doing this, what is different between the previous one and this one? Here loss of energy occurs. Loss of energy occurs. Because why loss of energy will occur? Because what will happen? First of all, what will happen? Why loss of energy will occur? Because first of all, this positive charge will flow and neutralize this. Make it first zero. After that, it will make it positive. Then it will become positive. Now, in doing this, we have loss of energy and it occurs in the form of heat in the wire. Okay, and how much energy loss is we see here? We see delta U is equal to C1 C2 by C1 plus C2 into V1 plus V2 ka whole square here. Okay, and in the previous one here loss of energy is equal to loss of energy. Here is minimum loss and it is given as half of C1 C2 by C1 plus C2 into V1 minus V2 ka whole square. Derivation is not required, so I am only using the formula. Any problem till now? Now we will do the numerical based on this. Any problem to anyone, we can discuss here once more. Any problem to anyone, you can ask with me. Any problem? Anyone, any problem? We can discuss here once more. Any problem? Feel free to ask anything. Feel free to ask anything. Oh, okay. That means nothing understood. Huh? Why you are all so silent? Not getting anything? Okay, please still not get anything. Huh? Why you use this formula in energy? Okay. I'm telling that. This is not, we're using this. It has some derivation, but I'm not going to the derivation part. That's why I've written here. Okay, how it is found, I tell you, but derivation is not required here. How you can find? How it is find? You find the energy here. initial energy half C1 V1 square, half like this, half C1 V1 square, half C2 V2 square, and this energy of this. Okay, and then subtract the energy between them. This will give you this formula of loss. But I'm not getting to derivation because it is not required for your exam. Okay. Okay, now let's move further. Let's move further. Okay. Please write, all of you comment. Let's move further. Okay, nice. This question, all of you have to try. I will give you 30-second time. This is the same concept which we have studied. Okay. Now, you try. Try once. I give you 30 seconds. You try, all of you try. All of you try. Try it once. All of you. All of you try it once. Any answer? Any answer? Any answer? Any answer? Okay, no worry. Let us see how we can solve this. No worry. Let us see how we can get our answer. Let us see. Let us see. It is telling that a parallel plate capacitor of capacitance C has been charged by potential difference of V. It is given that a parallel plate capacitor is charged by a voltage V. Okay, and one more thing, don't think that I am taking tough question. Okay, these all questions have been, similar type of question have been asked in your NEET exam. Okay, I am only focusing on NEET exam, not taking any JEE main or advanced question. Okay, so don't think like that. Okay, these all are type of question comes in an exam. Okay, now it is given that now the plates of capacitor are charged to, now it is given that now the plate of capacitor are charged to uncharged capacitor of capacitor. Now it is some, I think error is there. It is given that this charge capacitor, now what will happen after connecting here, it will gain some charge. Let us suppose Q, it will be CV. This capacitor having charge plus CV here, it is getting connected with another capacitor having capacitance of 2C, and it is uncharged, not having any charge. Find the common potential attained. Okay, what will be the common potential attained by here? Okay, what will happen? It will happen that some flow of charge will occur from here and it will gain this type of charge here. What will happen? We will see that initial charge was initial charge. After some time, what will happen? It will happen like this. Happen like this. Common potential will become V. Here capacitance C. Here capacitance 2C. Here charge will be Q1. Q1 dash is equal to CV, and here Q2 dash will be 2C into V. We will say like this, initial charge. Okay. It was given a potential V initially. We will assume here V1. Okay, V1. What we will do? We will write like this. Initial charge is Q, C. Okay, it is Q is equal to CV, initial charge. It will be equal to final charge. What it is? Q is equal to CV1 plus 2CV1. That means common potential V1 is equal to CV C will get cancelled both side like this. You can cancel both side. We will get V by what we will get? We'll get 3. That means final potential will be V by 3. Any problem to anyone in getting this question? Any problem? Any problem to anyone in getting this question? Any problem? I shall repeat once more. Any problem to anyone? Any problem? Please reply. Any problem? Okay, repeat again, sir. Okay, that's the answer. What we did, you see, initial charge. I have found the initial charge here. Initially, this capacitor will gain charge of CV. You can see it will gain charge of CV. You can see CV here. It is having charge CV. Q is equal to CV, and this charge, and it is having no charge. But when we are connected, we know initial charge is CV. We have written here initial charge CV. Now, when we connected both of them, what will happen? Some charge will flow this side, and they will get plus here and plus charge here. Let us suppose common potential is V1. Okay, what will happen? So new charge Q1 dash will be C into V1 here, and Q2 dash will be 2C into V1. Okay, we can say initial charge, that was CV is equal to final charge C into V1 plus 2C into V1, and after calculating this, we will get a value of V1. Any problem? Now, any problem? Okay. Now, second part is how we have to find the loss of energy. You can try once more. You can try once more. Try all of you. I give you 10-second time. Try all of you. 10-second time. Try all of you. We have studied the formula also. We have studied the formula also. Formula, what was the formula? Half C1 C2, that means C into 2C by addition of both of them into potential difference. What was the potential difference? Initially, we can see here it was having potential V and it was having potential 0. We can write V minus 0 like this, and we will get our answer. So that much joule. Okay, any problem? Any problem to anyone? Okay, got it. Any problem? Okay, now let's move further and see next question. Try this question. I give you 10-second time. 30-second. Try this. 30-second time. Try this. Try this. 30-second time. You try this question. Answer came. Read this question. Answer came. Anyone? Answer came. Anyone answer? Any answer? Any answer? Okay. No worry. Let us see. Let us see. I think you have done. Almost done. Let us see what is happening. It is telling that two parallel plate capacitor, 1 microfarad and 2 microfarad, are charged separately by 100 volt. That means two capacitor. One was 1 microfarad. It is connected to like this 100 volt. Okay. And second time we have connected 2 microfarad capacitor connected with 100 volt. Okay. Now what we are telling that we know if we have connected and it gets charged, it will attain a charge of Q1 is equal to how much? CV. CV means 1 into 100, that means 100 microcoulomb. And here charge Q2 will be 100 into 2 CV, that will be 200 microfarad. Okay. Okay, now it is telling that we are connecting. Now the positive plate of one is connected to the negative of other. That means positive plate. Simple question. I think it is based on our formula only. Okay, like this. Okay, negative potential. It is telling what will be the final charge. We know V is equal to what is C1 V1 minus C2 V2 by, you know, it will be C1 plus C2. We have studied earlier also. Or how we can solve? We can write here initial charge, add up all those charges here, but they are since connected in opposite direction, so we have to subtract here. Okay, subtract here. That means we have subtracted here. What it will be? It will be C1 V1. C1 V1, that means we have calculated greater one first by lower one by C1 plus C2. That means 3 microfarad. What we will get? 100 by 3. This much volt you will get. Okay, finally, now final potential Q1 dash will be C into V. Finally, 1 microfarad C into V is 100 by 3. That means 100 by 3 microcoulomb, and Q dash will be 2 into 100 by 3. That means 200 by 3 microcoulomb. This will be the final charge on each capacitor. Any problem till now? Anyone? Any problem till now? We can discuss it once more. Okay. And only also this is not only the method. We can solve it. We can solve it by step also. Initial charge is equal to final charge, like this. We will get the same answer we have done in our derivation also. Okay, only one thing we have to take care, that we have to take mod of air. Okay, we have to take mod air, not whether bother which one is greater. Always take mod air. Okay, greater charge minus lower charge. That I have done. 200 minus 100. Okay, now let's move further. Okay, now one question also, good question. Read this question. I give you 10-second time. I think 30-second time. You try this question. Try this question, all of you. Try this question. Try this question. I give you 30-second time. Try this question. Try this question. I give you 30-second time. Try this question. Try this question, read it once, and try it by your own. Try this question. Try. Any answer came? Any answer? Any answer? Okay, let us see. Let us. It is telling that air core parallel plate capacitor. That means if we are having air core parallel plate capacitor, recharge by connecting it to a battery. It is suppose we are having a parallel plate capacitor C. It is charged through a battery like this. Okay. Now, like this. Now it is telling that we are inserting. Now it is telling that now it is disconnected from the battery. Now this capacitor is disconnected from the battery. But if we are connecting it, but initially it was connected to a battery V, let us suppose potential battery V, it will gain some charge Q is equal to CV. If we have disconnected, but charge will be present here, plus Q here and minus Q here. Okay, capacitance C, charge is equal to CV. Okay, now it is telling that in the question part, it is telling that a dielectric slab is inserted of constant between the plates. A dielectric slab here, a dielectric slab like this. What we are doing, a dielectric slab is inserted here like this. Okay, and it is having dielectric constant of K. It is inserted here. Okay, it is telling that what will be the initial and final capacitance. Well, how we can write? Let us suppose initial capacitance. What it will be? We know initial capacitance was C, and after adding it, final capacitance will be K into C. Okay, first one solved. Now, second part, it is telling that capacitance done, initial and final charge. Okay, initial charge was Q initial. It was CV, Q final. Remember, charge will be only Q. No charge will be added because we are not connecting it through battery. Okay, so final charge will be also only Q. No change here. Okay, if it was connected through a battery, then final charge would be Q dash is equal to C, that will be Kc into V, like this. If it is connected through battery, then but not connected, so this will be our answer. Q will remain constant. Okay. Third, what will the initial and potential difference? Okay, initial and final potential difference. Okay, initial potential difference is V. Initial potential difference V, and final potential difference we can see. We know Q is equal to CV. Okay, V is equal to Q by C. That means Q, that is Q by C. How much C is? K by C. This will be answer. Final potential will be this. Okay. Now, fourth part. It is telling that find initial and final electric field. Okay. Initial and final electric field. Initially, we were knowing that E is equal to electric field is equal to V into D. This only final electric field. V will be Q by Kc into D. Okay. Fifth one. Initial and final energy stored in the capacitor. Initial energy for this one, we know it will be half C V square or like this, and for final capacitance, or we can write like this, Q square by 2C. But for final, we have to write like this, charge is same Q square, but capacitance is 2 into C becomes Kc. This is the final energy. Any problem to anyone? Any problem in finding anything here? You can ask with me. This is a very important case also. One of the important case. Any problem? Any problem? Shall I repeat once more? Please tell, please interact. What telling? Okay. Yes, no, I get confused. Please write, clearly write. I get confused in yes or no. You have written yes for what? I am not, I am getting confused. So please tell, write clearly. Please interact fastly, Let me see. Repeat again. Okay, let me repeat. Okay, I will repeat once more. Remember one thing, it was given that here, it was given that capacitor was here having capacitance C, okay, connected with V, Q will be CV. Second case, we have disconnected here, capacitor disconnected here. Now battery is disconnected here, but if you have disconnected battery, but the charge will be constant always. Okay, charge will be constant always. Okay, now we know initial capacitance will C from here. Final capacitance will be, we know Kc, K multiplying to C. Okay, initial charge here, you can see initial charge here. It will be Q initially CV, you can see here CV. Now here final capacitance you can see here, it will be also Q, that is CV, because charge will be conserved, no change in charge. Okay, no change in value of charge. Now third, initial potential, we know initially it was connected with V, initially V, finally V final, we know Q is equal to CV, V is equal to Q by C. Q by C means Q is constant, by C becomes Kc. We have written Kc here. It will be a final capacitance after inserting dielectric. In terms of electric field, we know here electric field. We know here electric field. Here it is electric field is equal to V into D, or I think V by D. Mistake here. V by D. Okay. Initial. Final it will be V by D. V by D. And what is the value of V? V value is this here, from here. Put it here. One thing you have to remember, it will be asked in your exam, value of electric field increasing or decreasing. You can compare from here. We know it is given here like this. We know V is equal to C by V. You can see V will be Q by C. It is Q by C into D. You can compare here. Q by C in D. That means I will write here, it is equal to electric field initial by K. So we will say that electric field is decreasing finally. Okay. You have to compare this with initial. Okay. Electric potential, it was V is equal to Q by C, and finally it is having Q by Kc. That means we can write Q by C as V. We can write V initial by K. That means potential is also decreasing. Charge is remain constant. Capacitance is increasing. Okay. We are talking about energy. Since we know formula of energy is this, but we know in this formula, using this formula, since Q is constant, we can use it more conveniently. What we are doing, we do like this: U is equal to Q square by 2C, and finally Q square is constant, Q is constant, and C is Kc. We can compare here, we will get Q square by 2C is initial energy. We can write initial energy by K. That means energy is also decreasing. Only one thing remained constant, that was charge. Charge remained constant. Conclusion first. Second conclusion, capacitance increased. Third conclusion, potential, electric field, and energy. All three of them decreases. Okay, any problem? Got it? Or confusion is present here also? Got it? Or you are not? Got it. Okay. Let me see further. Let us. It is Van de Graaff generator. Okay. Van de Graaff generator. Van de Graaff generator instrument. It is based on the electrostatics. Okay. It is given principle is static electricity. That it is called as it is also called as electrostatic generator. It is an electrostatic generator. Why electrostatic generator? Because it produces high amount of charge or high potential. What happened? We give here charge from here, and from here through a process of corona discharge. That corona, okay, and it was also phenomena. It is called corona discharge. Through corona discharge, charges goes through this belt here, and it get transferred to upper sphere, hollow sphere like this, and it transfer on it. It moves on it, okay, like here, and we create a high potential. Okay, it is written here. We get high potential, high charge particle is energetic charge particle, and 1 degree of generator principle we have to know. Only these 3 points are important for 1 degree of generator. Okay, which I have told. All things are same things are written here. Okay, now any problem? Okay. Okay. Lastly, one more thing. Lastly, you should remember, it is always tell that capacitor device, a device having capacitor, we should handle with care. Why? Because capacitor store energy. In millisecond of time, very small time, millisecond of time, and also supply energy for small time, That means capacitor behave as an instantaneous battery. It get instantaneously charged, very instantaneously charged, and also it supplies to the source. This is used in fan, motor like this. So it may be get charged. So it is tell that to handle the devices having capacitor, we should first discharge it. Okay. This is the health issue regarding capacitor. Now we are having some questions, but we will dealing with a question in our next class. Okay. You should go through all the concept of capacitor. Tomorrow we will taking good questions of capacitor, and we will ending the chapter tomorrow. Okay. Any problem till now? We can discuss. I will wait for you. 10 seconds. Any problem till now? 10 seconds. Otherwise, we will take questions tomorrow, and lots of questions are there. We shall take it tomorrow. Okay. Any problem till now? Any problem? We have dealt with many of the important concept of capacitor. Okay. Tomorrow we will be practicing more questions. Last one, sir. Okay, last one. Okay, this one. Okay, no problem. What I told you, health issue regarding capacitor. Suppose you are having a fan. Fan is there, a ceiling fan, like this, ceiling fan. Okay, ceiling fan has a cylindrical capacitor. This cylindrical capacitor takes energy from electric current and get charged through here, and instantaneously it also supplies to the coil, and with that energy coil moves fastly. If it will not supply to the coil, then coil will move very slowly and fan will only rotate slowly. So capacitor provide extra energy and fan rotate fast. Okay. Sometimes it is said that capacitor may be having some charge. So if we are trying to touch the fan or any devices containing capacitor, first we should discharge the capacitor. You must have seen electrician, what they do, they touch both wires and discharge the capacitor, and then they do other things. And when they touch the two wires of the capacitor, actually they discharge, they make the capacitor charge 0, and after that there is not any danger from capacitor, because from capacitor we can get a sudden shock. Okay, sudden damage can occur. Okay, that's why we first discharge the capacitor. Okay,